chest. Alright, I'm gonna go ahead and get started. Figured I would start it off with a joke. Why do sharks live in salt water? Because pepper water makes them sneeze. Oh. Alright, so last time we ended up going over the project structure. Well, not the structure, the idea behind it and why I wanted to create it. So now I'm going to go ahead and start with the actual project. I want to jump right in, get the code going. And so I've created just the bare minimum project for the OPengine, the OP engine. So right now, all it does, if I run this, building or something, there we go. So just a standard black screen, that's it. So for this game I want to implement V8 scripting. So I have Google's V8 engine integrated into the OP engine, and it's on OS X, Linux, Windows, and the Android platform. The only thing that the V8 engine currently doesn't support for devices is the iOS. But iOS has a JavaScript framework of its own, so it wouldn't be that hard to write a wrapper for the iOS stuff to implement the JavaScript stuff. So I don't really have to worry about multi-platform support using JavaScript. So that's my plan. So first I want to get something on the screen that's rendering an actual 3D model. So we're going to go ahead and get started with a simple game state. So a game state is kind of like a block of code that the engine uses. So right here we got assets, source. Okay, so I'm gonna come in here and look at our source. So right now all of the OPengine projects use CMake. So the engine is built with CMake, and so is the project, which then connects to the engine. So in here I'm going to, let's see, we're in the source. And I'd like to try to separate these out a little bit. I'm going to start this out just with game, and then in include, create a game folder. And I don't think we need sample. Yeah, don't need sample. So we're going to kill that off. Come in here and include directories, add source groups. So right here we've got source, and we want to also include the include folder. Now we are looking at main right now. Cut that, put that in source here. Oops, I want that to be include. And then we're also, so this add source group will glob files together. So anything that's contained within the project source directory, which is this OP.Wayward, and then within include, go back to include here, it'll grab everything in there. And so then if I also add /game to that, and I'll probably come back through and refactor these at some point, so it's not just a /game, kind of very abstract. Okay, let's see. So in game here, I want to make a game state. So for now, I'm just going to call it game again, and include. I'll try to keep the headers and the source code separate quite a bit. So I am compiling in C++, but I'm using a very C syntax. So now I've changed those, I can regenerate the project. Oh, that's for the engine now. Regenerate for Wayward. Allows me to reload. And there we go. Now we've got game.h. So not defined game. Find game and if. So engine.h pretty much includes every header file in the engine, and it's not great for compile time to include every header file, but really this game is going to be a prototype at best initially, and then I'll come through, and as I need performance improvements I'll come through here and I can change it up. But if you look at OPengine, you can see there's the core, data, human, and pipeline. So those are each of the layers that the engine has. So each one of these files is responsible for including all of the files that are responsible in that layer. So you kind of get the entire engine with just one include. So game state, I'm going to call this just game state. Let's go into extern, and then in game I've seen some people, some coders, they tend to like to use the relative paths. So instead of doing this, you do dot dot slash and then dot dot slash again to get all the way back to the root, like that. And I typically like to use absolute paths. You know exactly where it's at. It's always the root of your project source, and then you follow the path up. And if it's in the same folder, I'm fine with just doing like game.h and leaving it like that. So if you're using multiple headers, that's cool, but I like this approach just because I always know where it's at. Slightly more typing, but not that bad. Okay, so OP game state, and we are going to initialize it with some functions. So now if we go to game state, these are the methods that it's expecting. So game init, game state. Here's our timer. Keeps along with the typical update draw loop for a normal game engine. And then game exit. So now I can just fill these in. Update, game exit, and then update is going to return 0. So now, just to keep it simple, we're going to clear the screen to red, and then swap the buffer. So if you're not too familiar with these are pretty much just wrappers around OpenGL calls. So basically this will call GL clear in some form or another, and then present will do the exact same thing and just call it GL representative of it. And it's just a way to abstract this out, so then we can use OpenGL ES or OpenGL 3.3 versus 4.0, or even OpenGL ES or OpenGL 2.0, which is what the engine currently runs at, is 2.0 as a baseline. But we have the options to come in here and change the OpenGL desktop target. So right now 2.0 or 3.3. So right now I'm sticking with 2.0. If we need features from 3.3, we can update to it, but in order to maximize to all the devices, I'm going to stick with 2.0 until I absolutely have to swap over to 3.3. And we don't go down to 1.3. I just kind of got the renderable, or the pipeline that you can do there, but that's a little bit too low. Okay, so we've got that. So let's go back to main. And we're no longer going to use this. We want to use an active state, which is the game state that's currently active according to the game state. So you can only have one active game state at a time in the engine. We've got an idea of using sub-game states, so kind of like a menu screen on top of your game state already. You can get to that later. So this is going to call update on the currently active state, but we haven't set the state yet. So I need to include the game right now. So after we initialize, we're going to say gamepad or game state change do game state. And typically I like to keep anything that's global like that, or that's meant to be accessed globally, in all capitals. That way you can easily tell. And then application destroy, we're going to say active state exit. So these accept a couple of different things. So when you call exit on the game state, you can pass in the current game state that's calling exit, so the one that it's going to next. And theoretically, you could, each game state's got its own data, so you could determine what to do on exit of a state-to-state basis. Kind of use like a switch statement or something like that. Alright, so let's go ahead and compile it, see how we're doing. Succeeded. And there we go, we got a red screen. Okay, so now that we've got a red screen, I want to, so that's using the game state now. So now I want to come in here and start rendering some models. And we're going to go ahead and just clear this back to 0. Okay, so I want some, we're going to need some data obviously, so I'm going to create game data struct. And game.h includes engine.h, so we've got access to everything here. So we're going to start off, let's see, typically when I do this I like to keep the engine next side by side because it's got examples in here already set up. So if we look at, let's say I want to just render, actually, you know what, let's go for a textured model. Okay. So we're going to need a mesh, and we'll abstract this out so then it's relative to individual like characters on the screen. But first let's get something on the screen to render out. Mesh, in fact, this should be capitalized, accessed. We're going to need a camera in order to see it. Use a perspective camera. And then we're going to need a position to draw it at. And then we need a texture. So the texture will be used to render the mesh, or render onto the mesh. Okay, so the game engine uses a content manager. So when we first start up, we use OP loader's add default, and that will add some fairly typical loaders from the pipeline. So it'll load OPMs, which is an OpEffects model format, a fragment shader and a vertex shader, and then PNGs. So let's come back in here. First, let's create our game data. And let's keep it the underscore. Okay, so our mesh is get, and I'm probably just going to copy this puzzle block here for now to get something on the screen, and then we can go back through and get something better. Puzzle block, and then we need texture. So game data texture, and so there's two separate things you can do. You can do OPCman load, and then use OPCman get, which will load it, and then you can get it, so you can get it multiple times. You could also do the same thing. You load and get, and then do a get multiple times. But this just simplifies it and does it all in one step. Okay, so we've got our mesh and our texture. Now we need to create an effect. So the effects we're kind of playing with a concept right now of creating effect builders, I guess you would say. So kind of the idea that you could say, I want an OP effect position, and I need an OP effect normal, and pour them together, and then you'd say, okay, build me a shader off of these, and it would give you a fairly typical, kind of like cut and paste different parts of it around. I think it'd be really cool to get to that point, but I think there's a lot of intricacies with it. I mean, obviously you can like insert custom code into it in order to make it, I mean, otherwise the programmable pipeline is pointless at that point. Unless you really get all the permutations, but that'd be an intensely large program. So, game data. Let's see here. Game data. Need the effect. Render, create, effect, stride. Okay, so we need to load up our shaders here. Okay, shader, vertex shader. Shader. Alright, so we're loading up. Oh, actually, we're just getting right now. Load and get those vertex shaders and the fragment shader, and then we can pass those along to the effect creator. So this basically will compile the two resources together, and those are pretty much just text files. Nothing too different about them. Attributes. There are 3 attributes in that list. We're going to name the shader, or the effect, effect. And then the stride, so the only reason the stride is needed is so then you can offset the vertexes appropriately. So if this shader only needs the position and the normal, and you've got the position, the normal, the UV, and the tangent or something, you could offset the correct amount but still use the correct attributes. And so to do that, I can just do game data.mesh, and then there is a vertex size. And why aren't you happy? Effect pointer. Oh, this creates an actual effect, which that is perfectly fine. I'm happier with that. It wants me to use dereference those, and we are good with the effect. Okay, so last one, we need a camera. So OPengine perspective. We don't need an ortho for this. Our idea is to have it kind of top-down-ish, kind of on an angle. So our position, Vec 3. 1. 5, so that'll make it 5, 5, 5. Our target is going to be Vec 3, 0. So we're going to look at, so 5, 5, 5 looking down to 0, 0, 0. Our up, 3, up. So these are just global constants that are frequently used, so they're built right into the engine. 0.1F for the near, and we'll say 1.F for the far. Our field of view, just stick it at 45. So that's kind of like looking at it like this. And then our aspect ratio. Need a pointer for that. Alright, so now we can get to the point that we can actually start to render this. Okay, so I'm going to bind the mesh. And then bind effect. Get our typical world view projection matrices. The world for now is going to be, I'm just going to use the identity on it. Actually, we can do that. So the world equals the identity matrix. And then camera. Projection is pretty much the same thing. So that'll just fill in those matrices appropriately with whatever the camera is looking at. Clear active. So that just makes it so then we're looking at slot 0 on the video card. And this will return the texture slot that we're looking at when we bind the texture. So we do a texture bind. Data texture. And then 0.I. So this is the slot for the texture. Really should refactor that and just give it an OP render param texture that passes this along. Could just do an inline thing for it. These are going to bind, so I can just copy paste these. That'll bind our world view and projection matrices up to the effect. It requires a little bit of math. I mean, for games especially, it'll require some math, kind of trigonometry type stuff. But for the most part, you don't have to do too much, like, you don't have to get down into differential equations or something like that too often. If you're getting into, like, Unity or something like that, it'll do a lot of the math for you and you don't need to worry about it. But if you stick with 2D, then it's pretty typical, like, X, Y, and it simplifies things for you. Okay. So this has got a light, but I don't know that I need that. So let's do render mesh. You know what? I think I want to turn on depth. So that'll make it so then the mesh, when I start drawing it, doesn't have like the back draw on top of the front of it and start looking goofy. So use it the Z buffer as you draw in, it'll draw out. Okay, so I think we're good there if we compile. Compiled. So now I just need to get the assets. Any tips to learning C++? So typically I try to stay away from the actual C++ language itself. There's a couple of things that I'll use, like operator overloads and method overloading. But for the most part, like templates and stuff like that they're going to start teaching in college, I try to stay away from that. It adds a lot of complexity to it for games. For enterprise level software, for like financial industries or something like that, it makes a lot of sense. But when you're into the games, managing the tiny bits of code to push things through faster, templates and a lot of the C++ features aren't necessarily great for it. Okay, so we were looking for puzzle block. So puzzle block OPM. I'm going to take that one. We're looking for Tetris Broken. So these are just test assets that are in the engine. Tetris Broken. So these are predefined paths in the OP loader. So when the content manager looks for a .png, it's automatically going to look for textures / the name. So this will automatically redirect to textures and to model. And do I have all the shaders? So here's the different versions of OpenGL. So we look in common. We're looking for common / texture 3D, and it looks like we got that. Let's give it a run, and it run. Alright, so now we've got our model in there, but it doesn't do anything. So let's start getting some input into the game. Let's go back to main. I like to use this OP input system update. Look at that. All it does is it updates the keyboard, the mouse, and the gamepad. And it'll do it regardless of whatever game state we're on, because down here in the main method, we're starting up the OPFX engine, the OP engine, and then we bind these three methods to the values up here. You know what? I don't need this anymore. There we go. And then, so these OP main start, main end, and success, these are just defined, so then I don't have to worry about which platform we're on. So if we're on Android, Android's got a little bit of a different main method. And I'm sure iOS is, I actually know what, iOS is the same here. But, so there's different ways that you can start, end, and use a success for those different platforms, so that kind of abstracts it out. I'm still not sure if I like it, but I'm learning to deal with it. So then up here in the init and the update and destroy, the engine will automatically call these each time. So every loop this gets called, so it updates the content manager, which is pretty sweet because it'll only do it during debug. But in debug, if I save a texture, it'll hot reload it. So then I can like have Photoshop open on the side, resave a PNG, it'll automatically update and I can see it live. And so then every frame, it'll also update the input system, so the mouse, keyboard, and gamepads. And then we're doing kind of a global check here. If escape is ever pushed, then return 1, which tells the engine to quit. Otherwise, we do the update. So in gamepad here, okay, so right now we've got world as identity, but I can do OPNet for translate. And I can pass in an XYZ, or I can pass in a position, vec3, which I already had a position created. So So hopefully that should give us the same result. Yep. Alright, so now I try to keep the drawing and the updating separate, but I'm not sure how much of that I want to do of keeping them separate, because there's the cache locality idea of if you're dealing with a model, if you're updating the model and then later down the road you draw that model, you end up having to reload, and the context switches for the processor and the RAM becomes an issue. So I'm not sure how far down that road I want to go. I think I'll wait and deal with that when it becomes a performance issue. Might not be the best plan just because it'll get so ingrained, but we'll see where it goes. So the other thing is, once I get this going, I want to move this over into JavaScript and use that V8 engine. So we'll get there with the scripting too. Alright, so if actually I can even just do this gamepad data position dot x plus equals, so we're going to base it off of the timer, that way it doesn't matter what frame rate we're using or what we're at, because using OBS, the software I'm using to send to Twitch, is going to limit the frame rate down a little bit, and then if I were to stop streaming, the frame rate jump right up, and then it wouldn't look quite as well. Okay, so then gamepad. So you're going to use a gamepad here. Top. Player. So we're going to use player 1. We need an OP gamepad index of, oh, that's right, it's different now. Let's peek at that. OP gamepad 1. Just recently renamed these. Okay, so that gets whatever controller is currently player 1. So on Xbox controller, you usually see the 1, 2, 3, and 4 lights around it. So this will grab whichever one has the light in the 1 spot. So then I can do the gamepad left thumb X, and then pass in that player 1 controller. So that'll move the player left and right, or X and Y, and actually we're kind of looking at it down, so it'll kind of go into the screen and out of the screen based on which direction we move the left thumb. So I do that, I will get my controller. Yes. And it is out of there. Okay, so right now elapsed is in milliseconds, or not, yeah, milliseconds. So every frame that it passes around, it's probably going to be roughly 16 milliseconds. So 16, if you look at 1,000 divided by, oops, 16 divided by 1,000. I think I'm doing that right. So every 16th of a second or so. So elapsed is going to be large. So if we do something like this, and actually we can do a DT equals timer elapsed times 0.1. So that'll translate it back into seconds. So for every second we would move it 1 unit if the X is all the way over. So that should move it a lot slower. Yeah, that's about right. So now I'm using left and right for the control. That's cool. Action in there. So let's put it on the Z and then do the Y. So if we're looking at a typical XYZ coordinate system, you've got Z pointing outward on the ground along with X, and then Y pointing up. So this should, and I might have these, yeah. So pushing forward makes it go the wrong way, and then pushing left and right makes it go the other way. So if I just subtract instead of adding, it'll make it feel a little bit better as I'm looking at it. Oh, and it's gone. Where did it go? There it is. So that might even be a little bit too fast yet. Actually, let me get... Typically I like to use fraps just to check on frame rates. It's a little bit easier than having the program itself have this built-in component for it, when I can just use fraps and I get frame rate there. So right now it's at 60, which I think that's OBS limiting it down. Typically this would be running at like 800, 900 frames a second with no problem. And so you can kind of see right now I'm not touching the controller, and it's still moving. And that's the dead zone issue. So if I come in here, I can set the start. And actually, I think I'm going to even do this for globally here. So at the very start of the application itself initiating, I'm going to say gamepad set dead zone. So we can set the dead zone on an individual controller, or I could set it on all of them. So I'm going to set it to 0.1. So that should make it so then it doesn't start wiggling on me. Oh, no, it's still wiggling a little bit there. I guess that's up. Maybe it could just be that my controller is a little old. There we go. That's a little better. But now I've got the problem of if I push in the top left, it's going to go a lot faster than if I'm pushing left and right. And that's because it's using the X and Y that way. But if I were to do X and Y of 1 over here, then that's a significant amount more difference than the X and Y. So if I come in here, thanks. I can change this to be a vec2, do direction, then I can initialize it with these. So this will give us our X and Y in a direction, and then I can say vec2 normalize. Normalize is looking for, we do direction equals direction. So what that'll do is it'll take, well, ideally, why is it complaining? Oh, I need a semicolon there. So what that'll do is it'll take the direction, so regardless of where I'm at, if I'm up in here, it'll bring it back down to a 1, so it'll kind of do that unit circle idea. And so it'll no matter which place that I'm at on the controller, it's always going to go a constant speed. So direction.y and x. And so actually this might make more sense to access it like that. That way I know I'm on X and Y, but accessing it X and Z in the position, it doesn't matter which I do. But so now, oh, that's going really fast. And so that's because now that I've normalized it, oh, that's right, I normalized it. So normalizing it is going to increase that. I don't want to do that. So what happened is I've got a 0.25 or so in the X and like a 0.25 in the Y. but then when I normalized it, it would increase those to 1. So as soon as I touched the thumbstick just a little bit, it would bump over. And that's not what I want. So what I'm going to do instead, maybe I won't normalize it for now. Now let's just leave it like that. It feels a lot better. Okay. So now that I've got the little cube, the rendered, I want to start moving this over to the V8 engine, start getting JavaScript running. So let me see here. Go back here. I'm going to include our scripting stuff. Script.h. And then after we're done initializing, we're going to initialize the V8 engine. Let's make sure that works. Looks like we're good. Okay, so now comes some more fun stuff where let's include scripting up here. So scripting is a little bit newer to the engine yet. It's not fully fleshed out, so it's not included in the engine. You have to explicitly set it that you're including it. Once it's fully fleshed out, and I'm sure it's not going to crash, I'll bring it into the actual includes. We are going to use a compiled script. Compiled script. Alright, and now at the top here, data dot script equals script pointer. This is where it's going to start getting a little bit more fun. Script.js. And then game data dot compile game script equals script compile. Okay, so this. So I want to fill this in. You know what, I want to use that. And I don't even need to, oh yeah, I'll keep that there. Script. Alright. So I'm loading the gamescript.js in, which I'll create in a minute. And then as soon as I get it loaded, I'm going to compile it, so that way I don't have to recompile it every time that I want to run it. So first we're going to start with just trying to clear the screen with it. Script run function. So we're going to use our compiled game script, and we're going to run just a clear method. Oh, it's looking for a pointer. Alright, so now if I come in here and I don't have any. Okay, so we're in the scripts folder now, and I can create a gamescript.js. Now if I rerun this, load, should show up in my assets. Scripts, game script. Alright, so I told it that it was a function called clear, and I need access to the OP engine. So now I'm going to try and do our clear and we are going to try blue. Let's see if we can compile and run it. Clear it to blue. Oh, nope. Looks like we failed. Asset has not been loaded. Well, that was fine, because then it did load it. Compiled, game in it. Oh, no, it failed to get... Oh, you know why. Okay, so now this is where the asset manager comes in. So I added the default loaders, but the scripts aren't part of the main engine yet, so I need to add the loader for it. So OP script add the loader. And so now, so when it tried to load the asset, it couldn't find it. But now it looks like there is another problem. Let's see. Fatal error, reinterpreting is JS function failed. So where did you try to run? Right here. Script run. Script name is clear. Function clear. I told it there were no arguments to pass in, so that should be fine. Let's see. Is JavaScript function reinterpret failed to find? No, that was fine. So the V8 engine is a little bit tricky to debug. It doesn't give great errors. So it's saying that it's not a JavaScript function. Come back up here. Script compiled. Require OPengine clear. So I got the right data there. The result. It looks like it had a result. And there's a context. There's a global. So clear. See, I think I've got a scripting example here too. Let's see if we can find. That's what it is. Okay. So when I compiled the script, it created a JavaScript V8 engine context, but I didn't actually run it. So even though I compiled this, it didn't actually run this. So clear doesn't even exist in it yet. So I need to run the script. Really, I should probably have a compile and run function. I'll note that down. So compile, run, and now we should end up getting, there we go, that looks much better. Okay, so now for the fun stuff, so now that I've got that, I can come in here and I can just say 0, save it, and poof, it auto hot reloads it. So then as soon as it notices that the last write time is different, because it's in debug mode only, if it's in release mode, it's not going to do that for performance needs. But now I can come in here and start messing around with it. And then even better yet is there can be compile issues and it won't reload it. It'll attempt to compile it before pushing it over. So this is the start of what I wanted to get going. And so now I can move that around. Alright, so let's see. So now the next step after this is going to be deciding how far I want to go with it in JavaScript and how much of it I want to keep in C++ land. So ideally, the stuff that's going to change that's dynamic enough, I'm going to want to keep that in the JavaScript, but then the C++ stuff, like the performance stuff, will want to be in C++. So like drawing code in batched model rendering, that I'm going to want to keep in C++. But there is a little bit of a gray area in between there. Alright, so alright, well, let's see. I've got a basic textured model. Let me add another one and see if I can get player 2 going before the end of the stream. So I try to keep the stream about an hour, and I started at 8, so I got about another 10 minutes that I want to keep going here. And then next stream I can try and start refactoring some of this into like character components that'll be a little bit easier to manage. Okay, so if we were going to do player 2, then we are going to need position 2, and we'll rename these later. So the cool stuff here is that this is going to be initialized. Actually, this might not even be initialized to 0. That might have been what I was experiencing earlier. So what I can do is I can do an OP.B0, and I can say I want to 0 out everything in this, and it's going to 0 out the size of that game data struct. So all it's going to do is it's going to mark every value in here to 0, which that'll be really good for these positions, because then I know right off the bat that they're all 0, 0, 0. And that'll happen every time that I enter this game state. So if I happen to go into another game state and I come back, it's going to reset everything to 0, which might not necessarily be the best thing. Like if you had a menu and you started playing the game and you came back to it, you might want to be on the exact same menu. That way, like the menu option, that way you can just go up and down and you don't lose the context of where you're at. The next stream, right now I'm planning on next week Monday, just because I've got a lot of stuff going on this weekend. But I'm thinking about upping the amount of times that I stream to Monday, Tuesday, and Wednesday, and see how that goes. Okay, so we've got that one. So now here we can get player 2, gamepad 2, and then we're just going to duplicate this again and say player 2, and the exact same thing, 2, position 2, and now down here I've rendered the mesh, and now the only thing that changes is the world. Everything else about this mesh is going to stay the same except for where it's actually being drawn at. So if I come in here, I can set the matrix to position 2, and so this translate, if you only pass in the vector, it's going to build a matrix, whereas if I were to pass in a world like this, it's going to translate on top of that world. So it would translate it for player 1, and then it would translate it for player 2, and you never know where you're going to be at there. And then I need to render the mesh again. Now I should have 2 blocks. Yep, so there's 2 of them there. Now if I get a second controller here, so you actually need a cable here. Second is this one. Alright, and so now, any luck. I'm not actually sure how this is going to work with an Xbox One controller. I haven't tested this out. May not. Oh, there it goes. It just rumbled that it connected. And so there we go. Now we got 2 players on the screen. So that's the very start of our game. And so the next part, we're gonna start trying to get the scripting in to manage some of the character traits, like do speed, velocity, type, that kind of stuff, and then try to get the camera to watch these two, so then I can't go off the screen and lose track of where they're at. Actually, you know what? Right off the start. So this is going to be the whole parent-child game, so I'm going to want player 2 to be smaller. So I'm actually going to go ahead and do that right now. So world equals P for scale. So I'm going to make it half as big as player 1. And then we'll translate it. So it makes it smaller, and then it'll position it to where it wants to be. There we go. So now we got a little guy. But it looks like it's a little bit, it's off of the ground. So we can actually translate that down just a little bit. Do 3, 0. And then we're going to translate it down 0.25. Get that. Oh, I need to create it. Is that right? I seem to have gone in the other direction. Why is that? Oh, I did positives. I need to go down. Actually, I'm going to come up here. And for our delta time, I'm going to drop it just a little bit more so that I can get a little more fine-tune over this. There we go. Is that? So I think I was supposed to go... No, that's right at the bottom of that. Alright, so we got player 1 and player 2 in there. And we got scripting in, and we are good to go. Alright, so next time we'll get the scripting going with a little bit more fine-tuned integration with the characters. So I'll leave it at that unless anybody's got any questions. Alright, well, I will see everybody next week, Monday. Thanks for watching, guys.